Alright. We're live streaming, baby. We out here. First one. Coming to you, so hopefully you answered it. Bernice, what'd you get for the first one? Ooh, I love how you said x equals because I'm solving for 12. Very good. Make sure you actually write what letter you're solving for. Daniela, what'd you get for the second one? X equals -2. Very good. Now this next one got a little weird because it wasn't exactly on the table, was it? No. So it happened in between two numbers. What two numbers? 12 and 13. Remember, if you want to find exactly what it is, you could go to the graph, do second trace intersect, and figure out what it was. If you did that, it came out to 12.67. Or if you said it's in between 12 and 13, I would accept that for now. And then finally, this last one, what'd you get? 4. So, these equations, all we did on Friday was solve these. If I don't specifically say, hey, solve them algebraically, then take the easy way out. Just y1, y2, figure out what the heck the number is, and go from there. Dig? Alright. We do, however, need to talk about two main things. We're going to talk about when these problems go bad, and when we have some really gross things in there. After today, we'll know how to deal with all of this stuff. That's a lot of words. At the top right, I need you to put a quick reminder to yourself. These were the two things we talked about on Friday. The first one, when I am solving, what order am I going in? PEMDAS or reverse PEMDAS? Reverse. Simplifying, I will go normal PEMDAS. Solving, I go reverse PEMDAS. The other thing that is V important, I'm trying to isolate the square root term. I'm trying to isolate that thing. Every single time I'm doing this, I'm trying to get that by itself so I can move stuff around, and get my answer. Dig? Alright. We have to see what happens when they start getting coronavirus. No.
I thought this was America.
There's 3 cases in America.
Yeah.
It's here.
But there's more over there.
Yeah. Alright. Let's look at this first one. First one, left side. Is the square root isolated?
Yes.
Yes. So I don't have to move anything. I can start by getting rid of that square root. I get rid of that square root by squaring it.
Wow.
Both sides.
Whoa.
Everyone with it? The square root and the square cancel. I'm left with x plus 5. Be very careful. -1 squared. -1 times another -1 will be a positive 1. To solve for x, what do I do with that 5? Minus it, so I get x is equal to -4. I'm just subtracting 5 here, subtracting 5 there. Great. Everyone happy with that answer, right? Now, there's something that's weird about this. Oh my gosh. And this is why. Because up until this point, there's no indication that something has gone wrong in here. But there's something that's gone very, very wrong in here. If this is an answer, doesn't it mean that if I plug it back in, it should make this true? Yes? For it to be a solution. Let's test that. Let's see what happens. If I plug in a -4 into this, my original equation is x plus 5 is equal to -1. If I plug in -4, this becomes square root -4 plus 5 is equal to -1. -4 plus 5 gets me what?
1.
Just 1. Square root 1 is equal to -1. What is the square root of 1? 1. So I get this. 1 is equal to -1. Is that true?
No.
That is absolutely not a true statement. So is this -4, is it actually a solution?
No.
No. And it has a special name. We call this thing an extraneous solution. Bless you. Extraneous solution just means it's extra. When I type it back in, it doesn't actually make my answer true. So if this doesn't make it true, what should I write as my answer?
No solution.
No solution. Yeah. So what we need to add on to your idea of how to solve these is I always have to do this check step. Because there's really nothing in this process that tells me, that negative 4 is not the answer unless I check it. Now, I'm not going to give you any step that you don't need to do. The reason I'm telling you this is because you have to do it every single time with these problems. And most of the time, it's super easy. You just take that number, plug it in. Your calculator can even help you with it. And you just check, does it equal to each other? Yeah, great. That's the answer. If not, no solution. Dig? No. All right, let's do the last one. I'll let you do the middle one on your own. In this case, who will I pick on? Sasha. Sasha, is the square root thing all by itself? Sasha, what is there that needs to not be there? The negative 10. And how would I get rid of it, Sasha? I would add 10. So I'm going to add 10 over here. Add 10 over there. I get square root 2x plus 8 is equal to negative 2. Matt, do I have the square root all by itself now? Yes. So how do I get rid of it, dude? Square it. Square it. These go away. I get 2x plus 8. Han, negative 2 squared. What do I get? Nope. 4. Han, if I'm doing this, it's negative 2 times another negative 2. It'll turn into a positive. Negative times a negative turns into a positive. From here, I'm going to subtract 8 on both sides. 2x is equal to negative 4. Divide by 2, divide by 2. X is equal to negative 2. Now again, was there any part of that might have tipped me off that this is a bad answer? Nope. So I got to check it. I'm going to take that 2, this negative 2, plug it back into the original equation. So my original equation was this. 2 times negative 2 plus 8 minus 10 is equal to negative 12. 2 times negative 2 gets me what? Negative 4 plus 8 gets me, so I have square root 4 minus 10 is equal to negative 12. What is the square root of 4? 2. 2 minus 10. 2 minus 10, I believe, will get me negative 8. Is negative 8 equal to negative 12? No. So that negative 2 is an extraneous solution, and what do I write as my actual answer? No solution. Now, let me give you a little bit of information on why this is happening. The whole reason why the math is getting a number, yet it doesn't actually work, think about what type of equation this is. What kind of shape is a square root? It's like little half of it. What the math is doing is, remember how when we found the inverse of a parabola and we turned it on its side, we said, no, we can only take half of it? This is on the half that doesn't exist. This is recognizing, great, if I turn it on its side, this is the number that would be there if that other half was there, but because I can't have that other half, it's not there, and I can't have that as an answer. That's why the math does it, but when you plug it back in, it comes out to no solution. Dig? Not segregation. Alright, try the middle one. Try the middle one for me. See what you can come up with. I believe you should have gotten a 14 when you solved this. But when you checked it, what did you end up with? When you checked it, what did you end up with? Oh, wait, did you get a... I got a 12. Yeah. 14 is equal to 2. And is that true?
No.
No. So what do you write?
No solution.
No solution. Alright, let's flip it to the back.
I don't like the back. The back is weird.
Yeah, the back's got some weirdness. Here we go. The back is where we're going to really start flexing our algebra muscles a lot. No flex, sound. Alright, check it. Quiet from the peanut gallery. So, the process remains exactly the same. Is the square root isolated right now? Yes, there's nothing in front of it, and there's nothing behind it. So how do I get rid of a square root? I square it. So I'm going to square this side and square this side. The square and the square root cancel. I'm left with 30 minus x. If I square x, what do I come up with? X squared. Alright. Well, in this case, I have x's and x squareds. This is turning into a quadratic equation. I can't combine, so let's move everything to one side. How would I get this negative x toward this? Add it. So I'm going to add x. They don't combine, so I'm left with 30 is equal to x squared plus x. I'm trying to get everything to one side. How would I get that 30 over? Subtract it. Subtract it. And I would get 0 is equal to x squared plus x minus 30. Now, it's been a hot second, but you know how to solve these. You can either use the quadratic formula, factor, completing the square. I'm going to factor today because I think that's easiest with the ones that we have. Luke, you still with us, dude? No? Okay, cool. What I mean by factoring is, remember all those easy ones that had an a value of 1? This should be one of them. What are some things that multiply to give negative 30 but add to equal 1x in the middle? Some factors of 30 that are off by 1. 5 and 6. What's 6 times 5? 30. And you see how they're off by 1? So I just have to figure out which one goes where. It's going to be x plus 6, x minus 5. Because 6 times negative 5 is negative 30, and 6 plus negative 5, or 6 minus 5, gets me 1. From there, I can solve them pretty easily. X plus 6 is equal to 0. X minus 5 is equal to 0. Subtract 6, I get x is equal to negative 6. X is equal to positive 5. Right, it's the same process. There's just an additional, this is what we have done in our life before. Which one should I box? Or should I box both of them? How do we know? Yeah, I got to check them real quick. And these should be fairly easy to check. Here's my check step. First I take the negative 6, so square root 30 minus a negative 6 is equal to negative 6. Then take the 5, do the same thing. Square root 30 minus 5 is equal to 5. Let's do this one first, and it should be done by hand. Minus a negative turns it into a what? 30 plus 6 gets me 36. Square root of 36 is what? So is a positive 6 equal to a negative 6? Nope, that one's out. So same thing here. 30 minus 5 gets me what? Square root of 25 is what? 5 is equal to 5. There's my solution. Okay, this is a totally valid point, what Kenton just said. Looking here, and looking that it's going to be equal to negative 6. Is there any way I can get a square root that is equal to a negative? No, there's no way. There's no way I can take a square root and get a negative. Now, for those of you that venture yourself real big brain, remember how in the front I said there's no way to tell that it's going to get a no solution? Actually is a way. Now you cannot use this as justification on a test, but notice how when I isolated the square root right here, look at the opposite side. Was it positive or negative? Negative. Is there any way I can take the square root and get a negative number? No. Over here, when I isolated it, I had square root equals to negative 2. If I have a negative over there, it's not going to work. That only happens sometimes, though. It's a good indication that it might happen, but if you have some weirdness on the inside, sometimes that rule doesn't work. So you can't use that as a rule, but there are some tricks that you should be able to notice as you're going through. Dig?
So what you just said is that you like it.
Sort of. I do that pretty frequently. Alright, let's do these last two. Let's see if we can knock them out pretty quickly.
I don't like hurting people.
I do. What?
Hey, bro.
Alright, this one. Quinn. Hi. Are the square roots by themselves? Are they isolated? Yeah, I got the square root alone right here. The square root alone right there. So, I don't have to move anything. How do I get rid of the square roots? Square it. So I'm going to square this side. Square that side. So the squares cancel out with the roots because they're all by themselves. I'm left with 3 minus 2x is equal to negative 1 minus x. And then from here, I need to move some stuff around. Let's move all my x's to one side, all my numbers to the other side. It really doesn't matter which side I move them to, as long as I'm consistent. I'm going to move my 2x over this side. Bless you. So I get 3 is equal to negative 1. Negative x plus 2x will give me a positive 1x. Now check it, because some of you like to do this. Everyone look. I just moved the x to this side. I'm not going to move the 3 to that side as well. I'm going to move it to the opposite side. So I'm going to add 1. Add 1. I get x is equal to 4. Are you happy with that answer?
No.
No, I'm not. You got to check it.
For now.
Yeah, for now. So, I'm going to plug in 4. So I have square root 3 minus 2 times 4 is equal to square root negative 1 minus 4. 2 times 4, what do I get? 3 minus 8, I get
Negative 5.
square root negative 5. Over here, negative 1 minus a 4. Negative 5. Is the square root of negative 5 going to be equal to the square root of negative 5?
Yeah.
It's going to be imaginary, but it's still going to be equal to each other. I don't care that it's imaginary. I'm literally just seeing if it's equal to each other. They're equal. Great. That's an answer. Cool? So, I have different ways of doing this. The process, the exact same every single time. Isolate it, then I got to do some magic in between. Dig? Alright, one last one, and this one's a doozy of a problem. Turn to your neighbor and say, we will survive this.
We will survive. Die. We will survive.
Alright. Here we go. Everyone take a deep breath. We're diving in. Bernice, you still with us, sweetheart? Good. Bernice, I'm going to come to you. Now, listen to the questions I'm asking, because this is how your brain needs to work in solving these. Bernice, is my square root alone? No. What's with it? A plus x. So how would I get rid of it? Subtracting x. I'm going to subtract x. Subtract x. I get 2 minus x is equal to square root x. Now, my x is totally by its lonesome, correct? Great, so I can square it. I'm going to square this side, and I'm going to square this side. Everyone stop writing and look. If you say that this is going to be 4 plus x squared or 4 minus x squared, I'm legally allowed to hit you. What this is this thing twice. I have to multiply it twice. So 2 minus x times another 2 minus x. And this I have to FOIL. I cannot just say this squared and that squared. I have to FOIL it. So 2 times 2. 2 times negative x. Negative x times 2. And then negative x times negative x. Positive x squared. So I'm FOILing it. Just the first, second, outsides, insides last. Alright, let me rearrange this side over here. This is going to be x squared minus 4x plus 4 is equal to x. I'm just combining and putting that x squared up front. And again, I'm trying to get everything on one side. Let me move it toward the positive x squared. So how do I get this Lone Ranger x to the opposite side? Subtract it. Very good. Subtract it. X squared minus 5x plus 4 equal to 0. And this one should be real easy to solve. I should be able to factor this. What are some things that multiply to give 4 but add to equal negative 5? 4 and 1. But let's make them negative. So x minus 4 and x minus 1 is equal to 0. So I can set them each up. X minus 4 is equal to 0. X minus 1 is equal to 0. So I get x is equal to 4 and x is equal to 1. Now, let me make a point on what you want to choose. You know how I told you when you're going through this, you could do like the quadratic formula or factoring or completing the square? This one I think is the easiest to factor. You can use quadratic formula if you want. I just think it's really easy to go from this step to this step into that step, as long as you remember the tool for how to factor easy things. If it doesn't factor easily, then maybe you need to go to your quadratic formula. Cool? Done. Yes, no, maybe so. No, gotta check them. But the check step should happen pretty quickly. Let me use the 4 first. 2 is equal to square root 4 plus 4. Just plug in the 4 back in. What is the square root of 4? 2. So this is 2 plus 4, which is 6. For the record, when I am looking for the work, what I'm going to grade, Eileen, is this setup of the equation and this thing. If you can get there by using your calculator, I'm okay with that. But what I want to see on a test or a quiz is the plugging in, and it either it's equal to or it's not equal to. Dig? Then the other one, I plug a 1 in. 2 is equal to square root 1 plus 1. What is the square root of 1? 1 plus 1 is? Great, that one works out. So my 4 was an extraneous solution. My 1 ended up being my only answer.
Get out of here, 4.
Get out of here, 4.
4 eyes.
Everyone chill with that, yes?
Whoa, whoa, whoa.
All right.
What's wrong with having 4 eyes, bro?
Loser.